See if it's recording. Okay, now I said that. All right, let's try this recording stuff. It is going. Yay, life is good. All right, today we are talking about solving quadratic equations. However, we need to talk about a quadratic equation. My friends, what shape is a quadratic? A parabola. So a few things you need to know with this. A quadratic is just a polynomial with a degree of 2, right? It's going to be a parabola. So I want you to think about that then, because if it's a parabola, we know they can be all over the graphs, all over our coordinate plane. So when we work with this, we need to remember there's 3 types of solutions when you're working with this. All right, so let's do a quick review of the 3 types of solutions. First of all, your answers can be the following: 2 real solutions. When am I going to get 2 real solutions? Well, if I have a coordinate plane, that's when the parabola crosses the x-axis twice. All right, so it's when it crosses your x-axis twice. That's when you're going to have 2 real solutions. The other option that you have is when you have 1 real solution. All right, do you guys remember when you get 1 real solution, what the parabola looks like? How could I get only 1 answer, 1 place? What do you got? Yes, go. Perfect change, yes. When only 1 point is on there. So basically that means the vertex is hitting it, right? Could you have like a parabola going like this? And do you get 1 real solution? Or, you know, if we're having a different graph, so just imagine different graph, it'd be like the same type of idea. So when your vertex is sitting on the x-axis, you have 1 real solution. But do parabolas, do quadratics have to be touching the x-axis at all? No. So we also have, for this case, my friends, when you have 2 imaginary or complex solutions, remember? So 2 imaginary solutions. Friends, I'm not going to go into a lot of detail, but if you have answers with I in it, you're okay. Does that make sense? So remember, let's go sidebar. I equals the square root of -1. Those gives you the imaginary solutions, because otherwise you're going to have no real solutions or you're going to have imaginary. So just quick review of that. But that's when your parabola is floating way up there. There's no way it's going to cross the x-axis. There's no solution. So those are going to be your imaginary solutions. You're going to have answers that look something like this for like an answer. 3 plus, 2i or something like that. You could even go like 2i root 5. You're going to have an I coming out because you're going to take out that negative. But those are going to be your 3 different types of answers. They're all game. They're all fair game today. Okay? So, how do I solve for quadratics? Here's basically what you're doing. When you're solving, you're finding the zeros. You're finding the zeros of the function. You're looking for when it's equal to 0. That's what you're solving for. So if I was actually graphing these, I just look for, hey, does it cross the x-axis or not? It works pretty easy. Now, I'm going to go through, the first 2 methods are your easiest. They're the ones you guys probably feel the most confident on. And then we get to go to the worst. I'm going to go number 3, the worst. And then number 4, you're in the middle, okay? But I would say calculators should be always handy, so you might want to grab those just because you need to do stuff quickly. So let's make sure we're working with these. Warning again, do you notice this is all crammed on one side again, like all the notes? Do you think that's really a significant amount of space? Right on the back side of it, you are gonna be fine. But this is probably my favorite method, and I think this is the favorite method of everyone, is solving by the square root method. And someone's like, what in the world are you talking about? Solving by the square root method. This is what I mean. It's when certain looks come up that you can work with. For instance, what do? No matter what, you always isolate the squared term. And you'll see where we're going with this in a moment. And then you square root both sides. And I'm just going to give you examples, and you're going to see these really quick, and you're going to realize, like, oh yeah, this is the best way of solving quadratics. These are probably more simple quadratics when you end up using these. Or if you're just really good at this, you can see them quickly. All right, so here'd be my first example of what I'm talking about. You got 9 minus x squared is equal to 0. That's a quadratic. I have a second degree. But when I'm looking at this, I'm like, that's a difference of 2 squares. Do I really want to do that? The answer is, for some of you, no, because you don't recognize difference of 2 squares. But for the rest of you, this is very easy. The x squared is my only variable. Can I isolate it and put it on the right-hand side? Yeah, so I'm going to isolate it, put it on the right-hand side. You get 9 is equal to x squared. Now, what do you all naturally do? Square root it. However, if you forget your plus or minus in front, do you lose one of your real solutions? Yes. So don't forget you have to do the plus or minus, or you will get only one of your answers. So x is going to equal a positive or negative 3. Are you guys with me? Easy way of doing that one. Now, here's another time you can do this one, and it's not quite as isolated as what you think, but it's when you can use this process. What if you're doing work and you get a binomial being squared equal to a number? Is the squared term actually isolated? You guys agree with me? I have something being squared all by itself. There's no value in front of the parentheses or anything like that. It's isolated. Well, do the same process. What can I do to both sides? Square root it. So I can take the square root of that, go x plus 3 squared equals, don't forget, plus or minus the square root of 16. If you guys can help me do this so I can teach my freshmen a better way, I want you to think about what I could tell them. They really struggle even deciding what side to put the plus or minus signs on. If you have a good way of helping me explain to them, it's just easier on the non-variable side, let me know. Okay, so keep that in the back of your mind if you can think about that. So we get x plus 3 equals plus or minus 4, because squaring the square root simplifies it out. Then you get x is equal to a negative 3 plus or minus 4. Now this is when people make their math errors. It's not up above. It's like all of a sudden people start adding wrong. Just remember you're going x equals a negative 3 minus 4, and you're going x equals a negative 3 plus 4. So your two solutions are negative 7 and 1. But make sure you have two solutions. A lot of you can go to this step, and that's fine with me. I'm just making sure that you have both. If you struggle with that, show one more step. All right, you remember the good old days of doing these? These are nice, right? Here's another one I want you guys to think about on here. And it's not hard, but people don't think of it as this type of problem. What if I have this? 7x squared plus 12 minus x squared is equal to 0. When a lot of people see this one, they panic and they go, oh, I don't know what to do. Here's my thing. Do you have any terms besides the constant that are not x squared? Then this is an isolate your variable one. Okay, so you're thinking the same idea, and you're like, okay, I can work with this. Combine like terms because, you know, I would tell you that anyway. And then when you're seeing it, you're like, oh yeah, there's no x term, no anything to the first power. I don't have to worry about factoring. I can isolate with this one. So when we're doing it, we get 6x squared is equal to negative 12. My friends, divide by 6. X squared equals a negative 2. Are you guys starting to see where this one's going? When I take the square root of both sides, I still got to go plus or minus, but now I get x is plus or minus the square root of negative 2. Oh no, I can't take the square root of negative 2, so I need to realize that's now in my complex numbers. Do I get an imaginary answers? Yeah, so with this one, what's going to be my final answer for this? Yeah, I would put the I in front, root 2, but yeah, that's exactly it. You get plus or minus I root 2. Now, how did I get that? I use this idea. I could rewrite that as a square root of -1 times the square root of 2, right? And then we know the square root of -1 is pi. So if you get imaginary answers, yes, the answer is no real solutions, but could you please try to give me imaginary numbers? I haven't really pushed that on you guys hardly at all this year, but I do want you guys to be able to get those answers, especially if you're working anything with quadratic. Sound good? All right, awesome. Aren't those easy? Now, everyone's favorite. Solving by what? Factoring. My friends, I'm not sure how I'm ever going to get you guys to understand that factoring is a beautiful thing. It's a gorgeous thing. And it really is a time saver. And it works well. But you know what I think is the problem with factoring for most people? It's a lot of people didn't learn their multiplication facts well enough that they can do it quickly. I think that's the real issue. But I could be wrong. I could be totally wrong on this one. But for some of you, factoring is finally cool. All right. So how do I solve by factoring? Here's the number one thing that drives me nuts that people try not to do when they're factoring. And guys, I watched you do this year. Please do not do this anymore. If you're going to solve by factoring, all you have to do is set the equation equal to 0. Right? We're going to set it equal to 0. Then factor using the 0 multiplication property. What is the 0 multiplication property? Let me do a quick review of way back when. If you are multiplying together multiple things to equal 0, the 0 multiplication property says one of them at least has to equal what? 0. Do you know which? No. So that's why we set each individual factor equal to 0. We don't know which one is causing all the issues. So we want to know all of them that could cause the issues are going to be your 0. So that's why we do this. Now, again, when we review our factoring from first semester, number of terms should tell you how to factor. If you have 2 terms, do you look for difference of squares first? Yes. If you're given 3 terms, shouldn't we probably do logical guess and check? So yeah, like use the resources you know in order to do this. Guys, because we're supposed to know factoring at this point, I'm doing one example and only one. Are you guys with me on this? Okay, so let's do it real quick. Here's going to be our example for this problem, if it's going to write for me. Here we go. What if you have an equation that looks like this? 2x squared equals, and I'm going easy on us, I didn't decide to go awful. 2x squared equals x plus 1. Now, here's a few things with factoring that you want to remember. Do you want the term in front of your squared to be negative? No. Always make sure the term in front of your x squared is positive. So that's how I know which side to move to. Okay? I have my 2x squared, it's already positive, so I'm going to move everything on the right to the left. So number one thing happens, it's equal to what? Basically, are we solving for the zeros again? Yes. So make sure you're careful with your signs. So then we get 2x squared minus x minus 1 is equal to 0. How many terms do I have? 3. So we're probably going to use logical guess and check. So we go, and I set my 2 sets of parentheses up. Before I ever once worry about the numbers, I look at my signs. Guys, I look at that third sign. That's a minus 1. What does it tell me I have to put inside my parentheses for signs? Plus or minus. If you realize that, that makes your life really easy. I highlighted the 1 in front because that only really matters, and this sounds horrible, only really matters if I have a plus at the end, because then I know if I'm using both subtraction or both addition. But you need to be able to understand, it's not going to change here for me, that this is going to be a plus and a minus. And then the reason why we call it logical guess and check is we might have to switch signs around or numbers around, but we're going to check it. Number one error that happens, and I get cranky about with my students at this level, is when they don't check. Now, we have to do factors of 2. This is when life is beautiful, and I was nice to you guys. I gave you a prime number. It's 2 and 1. And then, okay, this is goofy, but be careful. What's the factors of 1? 1 and 1. I've got some really creative ones on that, okay? So just know, I've had factors of 2 as 1 and 1 before, okay? So like, make sure that we have the right factors. All right, with this one, did I put everything in the right location? Yeah, how did you know? I foiled it. I did the OI of FOIL. I did the middle terms, right? Basically, I got a negative 2x at a positive x. Do they add together to be a negative 1x? This is when I love using the surfaces because I can say yes and I can get rid of it. So with that, set it equal to 0, as you know. And some of you are like, do I have to set it equal to 0? The answer is not have to. If you're really, really good at math and you don't ever make errors, don't set it equal to 0. You're going to be fine. But for some of you, do you lose signs when you don't set stuff equal to 0? So be really careful, or you get the wrong ones divided. I got a lot of 2s sometimes instead of like here having it as 1/2. Show your work, my friends. So my solutions are 2 real solutions this time. And we have, oops, I forgot my negative. I wrote my negative. Brownies. We're recording, people. Come on, you bring up brownies. Oh, my word. Oh, my word. That was a good one. I caught it, though. I caught it. No. You just want to put this on a recording, that this is what you do to me. Yeah, I'll consider it. If it makes you feel better, if it makes you feel any better. I was literally last night going, I've really told them no a lot lately. I should probably make brownies soon. So just know. Wow, I think you're putting it recording just so I have to, right? Is that it? Yeah. I'll decide at the end of the period. Hey, I'm the one who makes them, okay? I'm the one who makes them. All right, let's do the hard one. Let's do the hard one. Let's do completing the square. All right, this is everybody's favorite. Here's the thing about completing the square. It's no one's favorite method. Can I just tell everyone that off the top of it? No one likes doing it, including teachers. But guys, we are going to be doing a unit very soon that you have to be really good at completing the square, or you cannot work with conics, okay? So it's important that you know this process. So completing the square, one I would avoid normally on my own. I want everyone to hear me on that. But it's a process that we have to be really good at. So what is the process with completing the square? I will tell you right now, the very first step is the same for the last one. Set it all equal to 0. You do the same thing. So that's the first thing, but then there's one more thing. Then you divide, if you need to, by the leading coefficient. And the leading coefficient is the one that's in front of the x squared. So no one's the one in front of the x squared. Then, coefficient, I think that's how you spell it. All right, so that's step 1. What's the next step? Then you're going to move, and this is weird because we just moved everything equal to 0, and then we're moving it back, but it's a way to help keep track of stuff a lot easier. You move the constant. The constant is what term? What is a constant, by the way? Yeah, it's a number without a variable. So it's the number without a variable. I'm going to move to the other side. And some of you are like, this is kind of double work. Kind of, but you'll see where we're going with this. Because you're going to have to do it again anyway. And then, or I should probably say of equation, make this a little bit more clear. And then you take, do you guys remember this part? You take half of the b and square it, completing the square. Thank you, sir. And then add to both sides. So a lot of this you'll remember more when we're doing it. Then there's the last thing. Then what do we do? Then we're going to solve using the square root method with a little bit of a twist. Do you guys remember hearing some of these steps, at least, when we're talking about it? So hopefully we get this one down. All right, we're gonna do at least 2 of these. All right, we get out of here. I wanna make sure we even have time to maybe do homework today. We get out here at 9:10. Oh, we're in a very good spot. Excellent. Okay, let's do our first one, okay? Remember when I say set everything equal to 0, when we talk about quadratics, this is what we want it to look like. ax squared plus bx plus c is equal to 0. Remember when we're doing this, we literally label everything a, b, and c, and we use that also for the quadratic formula. So that's the idea when we're setting everything equal to 0 is where they're coming from and where we're coming up with these letters a and b. So don't forget this. Remember a is going to be the leading coefficient. I always want, by the time I'm doing this, I only want a 1 ever in front of the x squared to make my life easier. B is going to be the term that you work with that we always divide in half. And then C is the one that we always move. But in order to understand this, I think it's probably best that we actually do a problem, right? So let's do this first one. What if our problem looks something like this? Let's make sure I've gotten it written out so it makes a little more sense here. Let's go 2x squared plus 2 is equal to 8x. Sure I've got my, yep, I got what I wanted. Actually, I wanted -8. Make that a -8, and then this will be a much better problem. Okay. What was our first step? Yeah, set it all equal to 0, right? So I get 2x squared plus 8x. Did I want to do it this way? I just want to make sure I got this one, yeah. Plus 2 is equal to 0. Okay, what was also in that first step besides putting everything equal to 0? Yeah. Not the constant over yet. In the very first step, divide by the leading what? Coefficient. I want a 1 in front of the x squared instead of a 2. But that means I have to divide everything by 2. So then I get x squared plus 4x plus 1 is equal to 0. Now I'm going to do what you just suggest. Do I need to move my constant now? Yes, so I'm going to move it over. So I get x squared plus 4x. And then this is where I'm a little bit goofy. But if I know I'm doing the completing the square, I literally go like this. Plus blank equals a -1 plus blank. The process with completing the square is you need to make sure you do it to both sides of the equation, or do we change the value of our equation? So if you do it to one side, you must do it to the other. So I always put physically the blanks there. Or guess what I forget to do? And I'm a teacher. I forget to do it to both sides. So now let's go ahead and let's do the third step. What's b in that equation? 4. So really what we're doing is here, I'm taking 4, I'm dividing it by 2, and what do I get? So then I do what with it? Square. So that's 2 squared, right? Which is, so I put 4 on both sides. Because if I add 4 to one side, I have to do it to the other, or I make my equation unequal. So what do we get then? On the right, we get a 3. Now, why in the world did I just complete the square? I'm completing the square to make what are called perfect square trinomials, which are really binomials that are being squared. So this x squared plus 4x plus 4 literally can be rewritten as a binomial being squared. And this is how easy it is to do every single time. If 4 is positive and you divide by 2, that's a positive 2, correct? That's what goes in. I go x plus 2, that quantity squared. Now, does this look familiar up above? Now can I take the square root of, good. Can I take the square root of both sides? That was great. Way to go. Wait, video. Good. Okay. So let me make sure. Oh, I love you guys. Okay. This is probably the most awake you guys have been in like forever on first hour. It's been great. All right. I'm trying to teach here. Okay. So I got the plus or minus. We have to take the square root of both sides. So we now get x plus 2. is equal to the positive or negative of the square root of 3. What's the one last thing you got to do, my friends? Yeah, subtract 2. And you can decide if you want to put it after or before, but a lot of times you go negative 2 plus or minus like the square root of 3. What are your actual two answers? I mean, that's in one spot. This is the cheating way of write it, so we have it down. So we got a negative 2 plus what? Root 3, and the other one would be x would be negative 2 minus root 3. Would be your two solutions. They're still reals, because you see when we're doing this that you could get probably complex numbers pretty quickly with this if your right-hand side ended up being a negative that you're doing. So it could happen. All right, do you guys want to do another one of these just to practice? Go to the back side of your page. Let's do the following one. And the reason why I'm doing this next one is because it has fractions. You can't avoid fractions when you're doing completing the square. I mean, you could, but that would be not training you guys very well. So let's try this again. We're just going to say solve by completing the square. Now, I need you to hear something on here, okay? You are going to be asked to do things very specifically on the homework. So they'll say like solve using the completing the square. That does not give you permission to use the quadratic formula even though you know it works, okay? In the real world, if I just said solve, that's what I want you to do. You pick the method that works best. But on the homework this weekend, because I think I won't see you guys on Monday, so like homework this weekend, make sure you do what it tells you to do in the directions. And then really, unless I specifically say something otherwise, you're going to be okay. You can just pick the method that works. But we're going to do this one solved by completing the square. So this is the basic one we're going to do. Here's your equation. We're going to go, let's do a different color. Let's go x squared plus 5x minus 7 is equal to 0. So, nice thing is, was it already equal to 0 for us? Okay, what is the next step? You're supposed to divide by the leading coefficient. Do I need to? No. No. Sometimes that's nice, okay? So no, you don't have to. But what's the next step? Move the 7 to the other side. So now I get x squared plus 5x plus blank equals 7 plus what? Blank. So this allows us to remember that we got to add to both sides. All right. So after we move the constant over, then what does the process tell us we have to do? Half of the b value. Yep. Say half of the b value, and it's positive, so it's 5 over 2. And then we have to do what to it? Square it. What's 5 over 2 squared? Be very, very careful.
Over 4.
Over 4. So it'd be 25 over 4. Make sure you square the numerator and the denominator when you're squaring a fraction. And so this would be over here at 25 over 4. Now, those of you who, this is where it's kind of fun. Those of you who are really bad at fractions, this is just when your calculator comes in really, really handy, okay? Because our next step is we have to simplify. So what's 7 plus 25 over 4? It should be 53 over 4, right? Because 7, if I change that into an improper fraction, that's going to be 28 over 4. And so we get 53 all over 4. Now, remember, we're also trying to write a perfect square, a binomial being squared. And all you have to do is put an x here. And then, guys, was that a positive or a negative 5 over 2? Positive. So it's plus 5 over 2. Now, can I use the square root method of solving? Yep, we have fractions, but guys, we're good. We can do this. So we're going to take, yeah, let's still keep it like here. Square root of both sides. So now I get x plus 5 over 2 equals plus or minus. All right, square root of 53 over 4. Let me remind you, can be rewritten like this. Now is that much easier to simplify? Yeah, that leaves a square root of 53, because there is no perfect square numbers that are factors of it, all over what? 2. Why did I do that? I don't know. All right. So with it, what's the last step? subtract 5 over 2 from both sides? So can I get x by itself? I'm still solving, so I got to isolate my x. So don't I really get a negative 5/2 plus or minus the square root of 53 over 2? You may leave it like this, or if some of you want to make it look really cool, could you do that because they have common denominators? Would that be a valid way to write it? Either one works for me. So here's the biggest thing about continuous square that stinks. You're going to get fractions a lot. So make sure your calculator is close by if you're not really good at fractions. Make sense? Are you guys good? All right, we have one last method, and this is, okay, yeah, do you have a question or were you just stretching? Yes, yes.
So, like, on the test, you do that process, you get, like, just separately, like, x is equal to -5 with 2 plus 53.
Nope, as long as you have both solutions, I'm good. Just know you're going to see it both ways. Just you're going to see it. And then some of these, like sometimes you don't want both solutions because like if you're doing this in a word problem, the negative sometimes doesn't work. Or sometimes the positive won't work because that's not what you're asking for. So it's again context of the problem. In this context, it doesn't matter for me. You're not going to be able to combine them any more than that unless you put it as a decimal. Then you're just giving an approximate answer anyway. All right, did that make sense? Does that rejar your memory about completing the square? How many of you did that? I know, did everyone do that last year? Okay, that's what, if you didn't, I would have been so distraught, I've been like, what were your teachers doing last year? Okay, all right, coming back here. Everyone's favorite. The quadratic formula. Okay. Quadratic formula. Can we do this one step? Because if you don't do this one step, it doesn't work. Number one step. Set all equal to 0. If you do not set it all equal to 0, it's not going to work, right? Are you ready? No. Okay. All right. If you need to go get a drink or go outside for a minute, you can. All right. The key with quadratic formula, the key with completing the square, the key with factoring is we set them all equal to what? 0. Then why don't you guys do that when you're solving? Are you guys with me on that? Like, when we were factoring all the time first semester, and I'm sitting there, I'm like, solve by factoring. And then you guys don't set it to equal to 0. And I'm like, the only method they really learned is equal to 0. Like, really? So, could we try to remember that now, at least? Are you guys with me on that? But let's have a little bit of fun. All right, who thinks they remember the quadratic formula? Okay, are you going to sing it? Or are you going to do like...
Tommy, you're in the musical, you got to practice. Yeah. Might as well even stand up. Minus the square of b squared.
He almost had it. Did you guys hear it? He almost had the Pop Goes the Weasel song going through everyone's head when you're doing that. You guys remember that? Like you memorize it with that way. And I've taught it so many years with the Pop Goes the Weasel tune that I have to like be careful not to like just say it like da 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 like every single time. Like all over to a like yeah, that's helpful. You're juniors and seniors now. We don't need to do that. But here's the big, oh no, you can sing it, I'm not, hello people, this is musical week, way high expectations, can't do it, can't do it. But here's the big thing, I need you guys to hear me on this. If you do not use parentheses when you're plugging into this quadratic formula, you will get it wrong. People will lose track of negative signs, the wrong thing is being squared. You must use parentheses. So here's the other cool part. Calculators are wonderful. They can help you do this fairly quickly, especially if they're going to let you have a decimal answer. Okay? But make sure that you use this. Now, this is one. I have some students I've had in the past that refuse to factor. Because what do they always use? Quadratic formula. I'm like, you just made yourself take a long time. But do they get the right answers? As long as it's a quadratic, they get the right answer. So I got frustrated, but I couldn't yell because it's okay. But make sure you have those. All right, so let's do this one. Let's solve this equation for me. I get 4x is equal to a negative x squared minus 3. What is your first step? Yeah, set it equal to 0. Which side are you going to go for? Right or the left? Left, because what do we want to be positive? It just makes life easier. Yeah, what's in front of the x squared? So we're going to go x squared, and then we're going to go plus 4x, and then we're going to go plus 3 is equal to 0. Now, this is killing me because it's so much faster than a factor already done. But we're going to do the quadratic anyway. Okay. But here's for some people, this is what they need to do. This is for most of you, probably not. Shouldn't you maybe, if you're struggling, write down what A, B, and C are? And then it's easier to plug into formulas. So let's write this one down. So I get x is equal to a negative b. So what are we going to get? A negative 4. And we're going to go plus or minus. Now I want a b squared. So guess what you're going to do? You're going to get in the habit of doing. Put it in with parentheses, please. Because what if that was a negative? Remember, a negative 4 squared is different than, correct? Is there a difference between those two? If you look here, and I have 4 squared, give me that first, you get a negative 16. But if I have the quantity of the negative 4 squared, do I get a positive 16? So you want to make sure that you are always putting in the right value. All right, so then we go minus 4. What's A? Notice parenthesis. What's C? Notice parenthesis. Are you starting to notice parentheses? Okay, and then when you're going with this, you got 2 times what? 1. Now, it's really awesome to have calculators that do great things, but these numbers are nice, so let's do it without our calculators here for a moment. 4 squared is what? 16, and then we have minus what? 12 all over 2. So I get a negative 4 plus or minus the square root of 4 all over 2. Keep going. What do we got? Negative 4 plus or minus 2 all over 2, right? All right, so what do we got here for this? Could we go, I know x is going to be a negative 6 over 2, or we have a negative 2 over 2, which we have to simplify, right? Where did I get those numbers from? That was not fast, so let's write it down. Okay, you have a negative 4 minus 2 over 2 is one of your answers, and you're going to have a negative 4 plus 2 over 2 as one of your answers. That's when you should be simplifying, right? X is going to equal what? Negative, is it negative 3 and a negative 1? Now, what happens if you get something maybe that looks like this? And you're getting your final answer. And you get something like a negative 4 plus or minus the square root of, let's say, 32 all over 2. You still have to give this in simplest form. So what is simplest form? Well, you still have to simplify your radical. Guys, what's the square root of 32 simplify down to? Say it louder. You guys were right. Should be 4 root 2, correct? Because 16 times 2 is 32, so square root of 16 is 4, all over 2. You've got to simplify further. If your denominator can go into both the numerator and the denominator, you can simplify. Can 2 divide into 4 in both of those cases? So you can easily get a negative 2 plus or minus 2 root 2. Those would be your answers. Another way of thinking about that, and I think for a lot of you this would make sense, can I take a greatest common factor of 4 out? So it's another way of doing it, like, oh, I took a 4 out, and then I put it all over 2. Do you see where the 2 comes from that way? I think it's just easier in my brain, like, all right, rewrite it as 2 fractions, simplify each. But I only do that if I can simplify both terms on top. All right, does that jar some memories? Yes, ma'am.
If you have a negative b, do you still think it like
When you're plugging it in?
yeah,
Yes.
does the negative or is it opposite?
Well, the outside one would be opposite. So let's just say I had, these were my values. A is 3, B is -5, C is 2, or something like that. When you're plugging it in to the equation, it's opposite B. You're going opposite a -5. And so when you're plugging it into the rest of it, you're going to have a -5 squared, and then you're going to do your normal stuff. Guys, could you have imaginary numbers with this? Yeah, so don't be surprised if you get like an I or something in your answer. And then it's like, yeah. I know, we haven't done that a lot, but we're remembering like, you did do this before. All right, any other questions before we quit this and you guys can actually start doing homework? Any questions? All right, I'm gonna be done recording if that's all right with you guys.